cMakeLists.txt. We don't need that, so let's close it from here. Now, we have the same concept in other IDEs like Visual Studio or Xcode. So we have a project, and that project contains a file that is the main file of our program. Now, let's close this window. I'm going to delete all this code because we're going to write it from scratch so you understand how everything works. All right, let's start with a metaphor. Think of your TV. Your TV we want to format our code just like a published article, okay? Now, after the function name, we type a pair of parentheses, and inside the parentheses, we can specify the parameters of this function. So a function can have 0 or more parameters. For now, let's not worry about them. We'll talk about them later. Then we type a space, again for proper formatting, followed by a pair of braces. Now, inside the braces, we can type the code for this function. So whatever we type here will be executed when the operating system executes our main function. Now, once again, in terms of formatting, there are two schools of thought for adding the braces. Some people like to add the left brace on the same line as the function. The other people like to put the left brace on a new line. There's really no right or wrong here. So whatever you prefer, just stick to that and make sure your code is consistent. In this course, I'm going to put the left brace on the same line where we define a function. Okay? Now, in this function, we want to write code to print something on the screen. And for that, we're going to use the C++ standard library. So earlier I told you that the standard library provides a bunch of capabilities that we need in almost every application. So on the top, we type hashtag include, and in angle brackets, we specify the name of one of the files in the standard library, that is IO stream, which is short for input output stream. In this file, we have capabilities for printing something on the screen or getting input from the user. So just like a supermarket has different sections, the standard library also has different files, each serving a purpose. Now, as we go through the course, you will learn about the other files in the standard library, okay? So back to our main function. Now here we type std, that is short for standard library. And this is like a bucket or a container for the features that are currently available to us. So the features we have imported on the top, okay? So if we type double colons, we can see all these features. Now there are a ton of features here. Don't worry about any of them. In this lesson, we're going to use cout. That is short for character out. Some people think this is short for console out. That is not correct. So using this object, we can output one or more characters on the screen. So we type a space followed by 2 left angle brackets, another space, and then in double quotes, we type the text we want to print on the screen. So hello world, okay? And then we terminate this line using a semicolon, just like how we terminate our sentences with a period. So in C++, this line is called a statement because it tells the operating system what to do. So whenever we type a statement, we should terminate it with a semicolon, okay? Now finally, we return the value of 0, and once again, we need to terminate this with a semicolon. But why 0? Well, 0 tells the operating system that our program is going to terminate correctly. If we return any other values, positive or negative, that means our program encountered an error, okay? So let's quickly recap what we have done so far. On the top, we included one of the files in the standard library for printing something on the screen. Then we defined the main function, which is the entry point to our program. Now, as you can see, the main function returns an integer, which is a whole number like 0, 1, 2, 3, and so on. And in between the braces, we have written the code for this function. So on the first line, we print something on the screen. And on the second line, we return the value of 0. As simple as that. This is your first C++ program. Next, I'm going to show you how to compile and run this program. Now, to run this program, first we have to compile this code to machine code that can be run by the computer's operating system. So the machine code is basically the native language that a computer's operating system understands, and it's different from one operating system to another. So if we compile this code on a Windows machine, we get an executable, but that executable only runs on Windows. We cannot run it on Mac or Linux. If you want to run our application on a Mac computer, we have to take this code on a Mac and recompile it to get an executable from Mac, okay? So back to our code. To run this program, we're going to click on this bar. Now look at the shortcut. On Mac, it's Control and R. Always use shortcuts because they make your life easier. So let's run this program. We get this little window down the bottom. This is called the console or the terminal window. It's basically a way to see the output of our program. So over here, you can see the hello world message. So we're using a console application here because console applications are easier to create, especially for people learning a new language. Building applications with a graphical user interface or GUI is way more complex. So once you understand the basics of C++, you'll be ready to move on to writing applications with a graphical user interface if that's what you want, okay? Now, let's minimize this window and make a tiny problem in this code. So I'm going to remove this semicolon. Now, let's rerun our program. All right, look, this time we get a compilation error pointing to this line. So the error is reminding us that we have forgotten a semicolon. If you're starting out, it's completely normal to encounter these errors if you have a typo or miss a semicolon and so on. Don't let that discourage you. Remember, Patience is the first skill of a good programmer. So if your code doesn't get compiled, pay close attention to this video, see what exactly I'm typing, compare it with your code. I promise, if you pay close attention, you'll be able to solve issues on your own. So let's fix the issue. All right, let's move on to the next lesson. Now, going forward, I want to change the colors here, and I wanted to show you how to do that because a lot of people ask me about the themes I use in my videos. If you're not using Clion, feel free to move on to the next lesson. So, on the top, we go to the Preferences menu. Then, under Appearance and Behavior, we select Appearance. Now, over here, you can I will see you in the next section. Now, let me give you a quick overview of how I've structured this course so you can get the most out of it. This course is the first part of my complete C++ series. Each part is about 3 to 4 hours long, so you can easily complete it in a day or two. In the first part, which is the one you're watching, we explore the basics. In this part, you will learn the fundamentals of programming in C++, data types, decision-making statements, loops, and functions. Now, throughout the course, I'm going to give you plenty of exercises to help you develop your problem-solving skills and build your confidence in writing code. In fact, many of these exercises are popular interview questions. In the second part, we'll explore intermediate-level concepts such as arrays, pointers, strings, structures, enumerations, and streams. And finally, in the last part, we'll be talking about the advanced concepts such as classes, exceptions, templates, containers, and more. So, by the end of this series, you will have a solid understanding of C++ and you'll be ready to apply it in real life. For example, if you want to build games with Unreal Engine, which is a popular gaming engine, you will have the necessary C++ skills to build games. You just need to learn about Unreal Engine. So I hope you'll stick around and master C++, one of the fastest and most efficient programming languages available. Hey guys, Mosh here. I just wanted to say that you don't really have to memorize anything in this course. I've put together a complete cheat sheet and summary notes for you that you can download as a PDF right below this video. So click the link in the description to download this PDF. So I have done my best to create the simplest C++ tutorial for you. So if you enjoy this, please support my hard work by liking and sharing this video. And also be sure to subscribe as I upload new videos all the time. Welcome back to the Ultimate C++ course. In this section, we're going to talk about the basics of C++. We'll cover variables and constants, naming conventions, coding mathematical expressions, writing to and reading from the console, working with the standard library, and comments. So by the end of this section, you'll be able to write simple but really useful programs in C++. Now, let's jump in and get started. Alright, let's talk about variables. In programming, we use variables to temporarily store data in the computer's memory. Now, technically, a variable is the name of a location in memory where we can store some value. Now, because the value can change, we refer to this location as a variable. Now, to declare a variable in C++, first we have to specify the type of data we want to store. Let's say int or integer for storing whole numbers. Then we give our variable a proper, meaningful name, like file size. Now, there are various ways to name our variables. We have various conventions. We'll talk about them momentarily. Once we declare a variable, then we terminate this statement with a semicolon. Now, I want to emphasize that you should always use meaningful names for your variables. Don't use abbreviations like FS, because someone else reading this code may not know what fs is short for. Also, don't go for names like f1 or f2 or thing. These are all cryptic and ambiguous, okay? So we're going to call this file size, and then we can give it a value like 100. So we assign it the value of 100. Now here we can combine these two statements into a single statement, and that makes our code shorter and more concise. So right here, where we declare our variable, we can give it an initial value of 100. This is called initializing a variable. Now we don't need the second line, okay? Now let's declare another variable for storing numbers with a decimal point. For that, we're going to use a different data type, that is double. We're going to talk about different data types in the next section. So in this section, we're only going to work with integers and doubles. Now we're going to call this sales and initialize it to 9.99. Okay? Now that we have two variables, we can print them on the console. So instead of hello world, let's print file size. Run our program, we see 100. Beautiful. Now, while initializing variables is not mandatory, it's a good practice to follow. Let's see what happens if we don't initialize file size and print it on the terminal. Well, immediately we see this warning. Let's take a look. The warning is saying variable file size is uninitialized when used here. Initialize local variable file size. So our IDE is complaining that we are using a variable that doesn't have an initial value. Let's run our program and see what happens. Take a look. Look, we get this random value, and if we run our program multiple times, we see a completely different value. This is what we call garbage. This is the data that is currently in memory. So, as a best practice, we should always initialize our variables before using them. So I'm going to set this to an initial value of 0. Now, in languages like C# or Java, we don't have to do this. If we declare an integer, it automatically gets initialized to 0. But this is not how it works in C++, okay? So this is how we can declare and initialize variables. And by the way, we can also initialize multiple variables on the same line. So over here, we can declare a second integer. Let's call that counter. So we add a comma and then declare counter, and optionally, we can initialize it to some value. Now, while this works, it's often discouraged. As a best practice, we should declare each variable on a separate line. So I'm going to remove this and declare another integer like this. Okay? Now I have a small exercise for you. I want you to write code to swap the value of two variables. This is a common interview question, so let me explain what I mean. We're going to declare two variables, A and B. Now if we print, I want you to write code to swap the value of two variables. This is a common interview question, so let me explain what I mean. We're going to declare two variables, A and B. Now, if we print A, we're going to see 1 on the terminal, right? Now, here's what I want you to do. Over here, I want you to write code to swap the value of these variables. So when we print A, we see 2, and when we print B, we see 1. Now, I don't want you to reset these variables, so I don't want you to set A to 2 and B to 1. This is not the right solution. Let me give you a hint. Imagine instead of these two variables, we have 2 buckets. The first bucket is filled with apples. The second bucket is filled with oranges. Now, if we have these 2 buckets in real life, how can we swap their content? Think of a solution and then use that idea to write code to swap the value of these variables. It's not that difficult. Just spend a couple minutes on this and then come back see my solution. So to solve this problem in real life, we need a third bucket. First, we empty our apples bucket into this bucket. Now the apples bucket is empty, so we can move the content of the oranges bucket here. Now the oranges bucket is empty, so we can move the content of the third bucket into this bucket. Now we have swapped the content of our buckets, right? So let's use this idea to solve this exercise. We declare a third variable, we can call that temp, and we initialize it with what we have in A, that is the value of 1. Now we can set A to B, so whatever we have in B, which is 2, is now going to be in A. And finally, we're going to set B to temp, so B is going to be 1. So now, if we print A, we're going to see 2 instead of 1. Let's verify this. So let's run our program. There you go. Beautiful. So this was your first programming problem. If you got stuck, don't worry. It's completely normal. As we go through the course, I'm going to give you more and more exercises to help you build your confidence. Next, we're going to talk about constants. There are situations where we don't want the value of a variable to change. This is where we use constants. Here's an example. Let's declare a variable of type double and call it pi and set it to 3.14. Now, with this, we can calculate the area of a circle, right? But what if somewhere in our program, I accidentally set pi to a different value, like 0? With this, our calculations are going to go wrong, right? This is where we can use a constant to prevent the value of pi from changing. How do we do that? Very easy. We type the const keyword before declaring this variable. Now look, on line 5, we have a red underline that is a compilation error. So if we hover our mouse here, we see the error saying cannot assign to variable pi with const qualified type const double. And also, if we try to run our program, here in the terminal window, we see an error. So take a look. This is the error. The error is happening in main.cpp on line 5 in column 8. And here's the actual error. Cannot assign to variable pi with const qualified type. Okay? So this will prevent us from accidentally modifying the value of this variable, or more accurately, constant. Now let's talk about naming conventions. So we have different conventions for naming our variables and constants, and different teams prefer different conventions. So there is really no right or wrong here. But let me show you the popular conventions. So earlier we declared a variable called file size. The way we name this variable follows what we call the snake case. So with this convention, we have to use lowercase letters to name our variables and constants. And if we have multiple words, we should separate them using an underscore. Now we have another convention called Pascal case, in which we should capitalize the first letter of every word. So the same variable using Pascal case looks like this. This is Pascal case. And by the way, the text that I put here that starts with 2 forward slashes, this is called a comment. We'll talk about comments later in this section, but for now, just remember that comments are a way to describe our code. They don't get compiled, okay? Now we have another convention that is similar to Pascal case. The only difference is that the first letter of the first word should be lowercase. So file size. This is camel case. We also have Hungarian notation, which is a pretty old notation and it's not relevant anymore. With Hungarian notation, we should prefix the name of our variables with a letter that specifies their type. So here we have an integer, so we use a lowercase I and then file size, just like Pascal case. This is called Hungarian notation. Now, quite frankly, this is a very old notation. It's not relevant anymore, but I still see people using it. I've seen it a lot in Windows source code. The reason this is not relevant anymore is because in the old days, we didn't have good editors. So if we declared a variable somewhere and we wanted to know its type, we had to scroll up to find the type of that variable. So with Hungarian notation, we could look at a variable and immediately tell its type. But this is not the case anymore because these days we have powerful editors. If we simply hover our mouse over any variable, we can see its type. So here you can see file size is an integer variable, right? So these are the popular conventions out there. In this course, I'm going to use camel case for naming our variables and constants, and Pascal case for naming our classes. We'll talk about classes later in the course. Now, if you don't like these conventions and prefer to use snake case, that's totally fine, but make sure to stick to your own convention. The more consistent your code is, the easier it is to read, understand, and maintain it. Next, we're going to talk about mathematical expressions. So you have learned how to declare variables and constants. Now let's see how we can write mathematical expressions for performing calculations. This is where the fun begins. So I'm going to declare two variables, x and y. Now we can declare a third variable and set it to x plus y. So what we have here is called the addition operator, and x and y here are called operands. So now let's print z on the terminal. So std :: cout z. Take a look. So now we see 13. Beautiful. We also have subtraction, multiplication, and division. But division is a little bit tricky. In this case, because we're dealing with two integers, the result of the division is going to be an integer, even though in reality, dividing 10 by 3 is going to result in a number with a decimal point, which we call a floating point number in programming. So if you run our program, we see 3, but what if you want to see a floating point number? Well, changing the type of z to double is not going to solve this problem because, as I told you earlier, if both our numbers are integers, the result of the division is also going to be an integer. So to get a floating point number, we have to convert one of these numbers to a double. So take a look. First, the warning goes away. Now, if we run our program one more time, look, we get 3.3333, okay? So this is how division works in C++. Now let me revert this back to integer and integer. Now we have another operator called modulus, which returns the remainder of a division. So what is the remainder of division of 10 by 3? It's 1. Let's verify it. There you go, okay? Now, using these operators, we can modify our variables. Let me show you what I mean. So for simplicity, I'm going to remove y and z. We only have x and we're going to print it on the terminal. Let's say we want to increment x by 5. Here's how we do it. We type x equals x plus 5. So first, this piece of code or this expression is going to get evaluated. The result is 15, and then the result will be stored in x, okay? Now, similarly, we can subtract 5 from x, we can multiply x by 5, and so on, okay? Now, we also have two more operators you need to know, and they are increment and decrement operators. So let's say we want to add 1 to x. We can say x equals x plus 1. That is totally fine, but there is a shorter and more concise way to write this code. We can say x plus plus. This is the increment operator. We also have decrement operator, but we don't have the equivalent for multiplication or division. Only increment and decrement, okay? Now, this increment operator, there are two ways we can apply it. We can apply it as a postfix or as a prefix. Let me show you the difference. So I'm going to delete these two lines. Let's declare another variable called y and set it to x plus plus. If we apply this as a postfix, first, the current value of x, which is 10, is going to be assigned to y. So y is going to be 10, and then x will be incremented by 1. So but y is going to be 10. Let me show you. So we print x is 11, but if we print y is going to be 10. Okay, so let me add this as a comment for clarity. In this case, x is going to be 11 and y is going to be 10. Now, what if we apply the increment operator as a prefix? So we declare another variable and set it to plus plus x. In this case, because we applied this operator as a prefix, first, the value of x is going to be incremented by 1. So x is going to be 11, and then the result will be stored in z. So in this case, both x and z are going to be 11. Let's verify it. So if we print z, well, in this case, z is 12. I made a mistake because in the previous statement, we incremented x by 1. So if we comment out this line, it's not going to get executed. So now, when we run our program, x is going to be 11 and z is going to be 11 as well. Let's verify it. So time x is going to be 11 and z is going to be 11 as well. Let's verify it. So here's z, beautiful. And let's also print x. There you go. So here's what you need to take away. If you apply the increment or decrement operator as a prefix, first, this piece of code is going to get evaluated. So first x is going to be incremented by 1, and then the result is going to be stored in the other variable. In contrast, if we apply this operator as a postfix, first, the current value of x, which is 10, is going to be stored in y, and then x is going to be incremented by 1. Hey guys, Mosh here.